Section 13.5 is about the law of cosines. This law, like the law of sines, can be used to find unknown measures of a triangle, except this time we use cosine instead of sine. You see there are three versions here, all based on a leg and an angle opposite it. And you can use the law of cosines when you have the measure of two sides and an angle between them, or the measure of all three sides of the triangle. So here's a triangle that we need to solve for, and we'll use the law of cosines to do it, because we know angle C, and we know the side that's on both sides of angle C. Now we don't know the C across from it, so we're going to use the law of cosine that uses C squared. So here's the law of cosines, and we're going to plug the values in. It doesn't matter what we put in for A or B, so I'm going to make A the 18, and I'm going to make B the 24. Now as you plug this into your calculator, I find that I get less errors if I just take these two numbers to add them together. And 18 squared and 24 squared gives me a 900. And then this is 864 times the cosine of 57 degrees. Now when you plug that into your calculator, be careful to use parentheses, but you're going to find out that C squared is 429.4. That's an approximation, it's a decimal approximation, so I should use the squiggly equal sign. And then to get the C, we'll take the square root of both sides. So C is approximately equal to 20.7. That's side C. Now to find the other two angles, I'm going to use law of sines. I'm going to find out A by taking the sine of angle A over side A, which is across from that, equals the sine of angle C, which is 57 degrees, over the side that's across from that I now know to be 20.7. That's the law of sines. And then I'll solve that. So cross multiplication gives me this, so sine of A, then if I plug that into my calculator, is 0.7293. And then I'm going to take the inverse sine of both sides to get angle A by itself. So angle A is the inverse sine of this number. Plug that into the calculator and you get about 47 degrees. So I'm going to come up here and say angle A is a 47-degree angle. And then to find the last angle, angle B, we take 180 minus the 47 and the 57 that I already know, and I can find out that angle B is 76 degrees. So we use law of cosines to find C, we use the law of sines to find angle A, and then we use the fact that all the angles in the triangle are 180 to find angle B. This triangle, we know all three sides but none of the angles, so we can use the law of cosines to find one of the angles. I'm going to focus on angle A, which means I'm going to use the law of cosine that starts with A squared. So if I plug everything in, this is what I get so far with my numbers plugged in. I'm going to take the 9 squared and the 7 squared and subtract them from both sides. And now, because I'm multiplying cosine A times all of these numbers, I'm going to divide both sides by -2 times 9 times 7. That will cause these to cancel out, so I'm left with cosine A equals all this, which I should be able to type this into a calculator and get a number from. So if you do this properly with parentheses and everything, you're going to get 0.7540 equals the cosine of angle A. Now to get angle A, we have to get rid of cosine, so again we take the inverse cosine, inverse cosine of both sides. So angle A is the inverse cosine of -0.7540, which you can type that into your calculator. So angle A is 139 degrees. Well, now that I know one of my angles, I can use the law of sines to find one of the other ones. So let's use the law of sines, and we'll say sine of B, which we don't know, over 9, because that's what side B is the sine of 139, because we know that, over the side that's across from that, 15. We'll use cross multiplication here. So we'll type this into a calculator and then take the inverse sine of both sides. So find out that angle B here is going to be 23 degrees. And so now I know that angle C is 180 minus the 139 from angle A and minus the 23 from angle B. and that's going to be 18 degrees. So there I've solved my triangle. Again, law of cosines was the first thing I used, then law of sines, and then the fact that all the angles equal 180. So in this slide, you see that because you know law of sines and cosines, you can use either one of those to solve certain cases. But it all depends on what you're given. The only thing I want to point out to you is this second one, if you remember, if this is the case that you're given, you have to make sure that you check to see if you have one solution, two solutions, or no solutions. Because as we learned with law of sines, the possibility exists for either of these three cases to happen. In this real-world problem, we see that we have a rescue helicopter that has a base here. It's got a hospital here and an accident here at spot A. We know some pieces of the triangle. We know two of the sides and the angle between them, and we're trying to find this side that's across from angle A. Well, this is a perfect setup of a triangle that has two sides and their included angle. So we're going to use the law of cosines to solve this. Now, because we know angle A but not side A, we're going to use the one that starts with A squared. So here we have A and B plugged in as well as the angle A, so cosine of 130. If we type this into our calculator properly using parentheses, we're going to get 7,417.5. Then we'll take the square root of both sides and find out that the length of A is 86.1, which we can label here as miles, and that's how far the plane has to fly.